Now that we know where all the wires go and what connects to what, it's time to start actually wiring things up. I'm gonna start by replacing the connectors on the throttle, the regen throttle, the brake levers, and adding connectors on the switches that don't have any. Over here, I have an extra Saviton controller. It's a different type, but it has the same connectors and we can use it for reference. Let's take a look at the throttle connector. It's a 3-pin connector. It's ground all the way on one side, signal in the middle, 5 volts on the side. In our auto connectors kit, we'll find the matching 3-pin connector. The connectors in the kit are separated into plastic housings as well as the actual pins. So I'm gonna go ahead and grab 3 pins and I'll take our throttle and I'm gonna cut the connector off because we don't need it anymore. So there's our throttle. I'm gonna go and expose a little more. Now with the wires exposed here, we can either crimp or solder the pins on. I pulled out some helping hands so you could see this better for the video. Now that they're all soldered, the connector kind of expects that you've crimped it, so we need to squish down the back a little bit to make it fit. Now all the pins can fit into our connector from the back side. So for reference here, we have the Saviton throttle connector, we have this connector, and let's put the pins in the appropriate order. So red, and then our white is our signal. Sometimes the signal colors are different. Generally positive and negative are the same color, so match red and black, and then white goes to gray. And there's our throttle with a new connector. And it plugs in fine and unplugs fine. Now, the regen throttle we got already came with these pins, so I think we can just put these into another 3-pin connector. And so for reference, we have the other connector here again. We've got positive, throttle signal, and then ground. We'll make sure we're going in the right order. Positive, signal, and ground. 3 clicked into place. That connects good, everything lines up, color's correct. There is our regen. I've got this switch that I'm gonna use for enabling or disabling headlights, turning on or off. We'll just go ahead and strip the wire, and we'll use a 2-pin connector for that. And there we go. Now I'm also gonna put 2-pin connectors on the brake levers. They come with these connectors on them, but I'm not sure what they're called or where to get them. So I'm just gonna cut and extend the wire so that I can put the connector on the other side. And I'm gonna give it like a couple feet so that the other side can be connected inside the frame when I run this in the frame. And now we've got 2 extended brake levers. I'm gonna put another 2-pin connector on both of these. And sidebar, I've been using male connectors for the switches. It shouldn't really matter considering both ends of the connector are protected, but that's what I'm doing. So now we've got 2 extended brake lever switches with connectors. All right, next up we've got this lovely guy. This comes with a connector on it that I don't have the opposite side to. And after depinning the connector, I realized the pins don't fit into the style connector we have here. So unfortunately, I'm gonna go ahead and have to cut them. I am gonna replace them with this 9-pin connector that we have in the auto connectors kit. And I'm gonna use the female connector instead of the male. That way it can fit through the hole in the bike where it needs to go. Now, in repinning this, I'm gonna be very careful to make sure the orientation of everything stays the same. Phew. Now with this wired up, I'd like to start wiring the receiving connector. Let's start with the 12-volt inputs. We have the horn 12-volt input, we have the headlight 12-volt input, which is switched, and we have the signal input, also 12 volts. I'm gonna grab 3 red 18-gauge wires, and let's put some pins on the wire. And now referencing our connector diagram, as well as plugging it in to check, we can plug in these wires and make sure they go to the right places. I'm gonna grab my label maker. On top, we've got the 12-volt signal input. Then facing the connector from the rear, on the right side, we have the 12-volt input for the headlights. And on the bottom, we have the 12-volt input that's used for the horn output. Next, we're gonna put cables in for every pin except for the bottom corner, and then we'll label them. All right, so I wanna start wiring up the CT22 display, but since that display and also the DC-DC need to get power from the battery, I figured we'd set up those wires first. Now, over here is basically what we're gonna need to make. These ends here go to the controller. These thick wires go to the battery connector, and then these thinner wires can power the DC-DC as well as the key switch. Our DC-DC is pretty small, so we're using 18-gauge wire. I'd like to show you the process of making this, but unfortunately it looks like I've run out of high amperage crimps. That being said, I can show you on something like this from Home Depot. While you should not use one of these for high amperage applications, you can still crimp it the same way to show how it's done. So you take your thick 6-gauge wire, cut away some of the insulation, take the thinner wire, kind of fray these ends a little bit, intermix these a little bit, and then spin them back up together. Now, if you put the crimp over it, it should pretty evenly distribute the force when you tighten it down. Usually I put it on the table, and that's crimped down. Now, I'm gonna say it again. These Home Depot tie downs, these things suck. You don't want to use them on your battery. The only reason I'm using this here is to show you the process. Anyway, once this is done, you'd throw some heat shrink over it and you'd be left with something like this. I had these left over from an old build, so I stole them for this one. Now comes the most fun part. And by most fun, I mean least fun. Soldering the battery connector. This is a QS8 connector. It's not what ships on the Onyx battery, but I did swap it out a really long time ago because it's a nicer connector than the Anderson plug that comes with the Onyx battery. You can still use the Anderson plug if you'd like, but since I already swapped the battery connector to a QS8, we're gonna go ahead and use a QS8 on this end too. This connector is incredibly robust. It's like a high amperage version of an XT60, but soldering it is a major pain because it dissipates the heat very quickly. First, you're gonna wanna take the cover and feed it over the wires. While your soldering iron is heating up to the hottest temp it can do, we'll strip the cables. Now that we got the cables stripped, let's pull out the helping hands again. Now, with most high amperage connectors, actually, with almost all connectors, you usually wanna tin the wire and then tin the connector and then solder them together. With a connector as large as a QS8, most soldering irons won't be able to melt the solder you put on the connector and the wire if you do it separately. So usually I just do it all in one go, and I move the soldering iron around the connector to distribute the heat evenly and make sure the solder wicks into the wire fully so you don't get a cold solder joint. So there's the best I could do. Not exactly beautiful, but with the QS8, if it's a solid solder joint, if it's not a cold solder joint, I'm happy. It doesn't have to be beautiful. These things are a pain. And the worse job you did soldering, the harder the cover is to put on. I did it. Yeah, these things are no fun. Another thing I like to do is cover this up with shielding. All right, so this is our V+. This is our 72 volt nominal battery direct wire. So let's pull out our key switch here and let's check what we've got going on with the multimeter. So in the off position, let's go to continuity mode on the meter, and then we'll check this connector here. So nothing in the off position, continuity in the on position. Cool. So this we can use for our ignition. Let's check this other connector here too. Yes, so this connector is the reverse. This connector has continuity when the bike is off and does not have continuity when the bike is on. So we're gonna ignore it. We'll just use this connector here. So I'm gonna take the 72 volts key wire and we'll put a pin on it. And before we connect this to the key connector, I'm gonna make a splice in it over here. I'll throw a piece of heat shrink over it, and we're gonna grab the DC-DC connector here. The thick red wire is the 72 volt input that gets battery power the whole time. So we'll join that here. Now we'll solder it, cover it, and heat shrink it. Now I'll plug this into the key connector. Let's grab some more wire for the key connector output, and I'm gonna fold this wire in half and strip it in the middle. In the middle, we'll put a pin that goes to the key connector as well. Sweet. So there's our key switch. Plugs right in. Extra wire we don't care about. So DC-DC over here has power the whole time. Now we'll connect the enable wire for the DC-DC to one of those two outputs we just made. So now when the key is in the off position, the enable wire is low. And when the key is in the on position, the enable wire is high. Now we've got one more enable wire, and that will go to the Saviton ignition. Now, if you remember, the Saviton ignition was a 1-pin connector, and they actually send us the connector to use for that. So we'll solder that up and slide that into the connector. Now our Saviton ignition is complete. Now when we turn the key, the DC-DC gets enabled and the controller gets enabled. There's a few more connectors here. This yellow is our 12 volt output, and these two grounds will join together. And I also connected the 72 volt ground to the grounds for the DC-DC. Now that we have the battery positive voltage and the ignition wires running to both the Saviton and the DC-DC, I realize we have to do the same for the CT22. We can do that pretty easily by depinning the ignition connector for the Saviton and soldering one more spliced wire under that for the CT22 ignition, and by depinning the battery positive wire from the key switch and splicing one more wire onto that. Now to recap what we have going on here, we've got the battery connector with positive and minus from the battery. Positive runs out from the connector, it goes to the key switch, it goes straight to the DC-DC, and it will go straight to the CT22. It loops through the key switch and comes back into ignition wires for the CT22, the DC-DC, and the Saviton. All the negatives are connected together, and this yellow wire is our 12 volt output. All right, let's start wiring in the CT22. We'll grab a 9-pin connector here. That fits. Let's check our 4-pin connector. Great, and now we can start soldering some pins. All right, and now we can start plugging pins in. Let's grab the 4-pin connector and plug it into place. Let's grab the positive from the battery and feed it to the yellow wire, or pin 1.
make sure that all lines up, and it does. Great, and now we can run the ignition pin to the red wire, pin 2. Now, pins 3 and 4 on this are ground, and since we're joining grounds together, we can wire that up now. And with that, we can pin up the other 2 pins on the 4-pin connector, and then when we plug that in, let's just visually verify one more time that the black wires are going to the green and black wire, and the yellow wire goes straight to the battery, and the red wire goes straight to the ignition. Great, we still have a loose ground that will tie in. So we'll grab one of our other ground wires and we'll splice there, splice here, and we'll join that. All right, let's start with the 9-pin connector for the CT22. Something easy to connect right off the bat is our 12-volt line. That's pin 5, the black wire labeled LED power line. Even though it's black on the CT22, we'll use red because red is our usual color for positive. Next, we'll find the yellow 12-volt output from the DC-DC, and we'll splice this in. I'll leave that exposed so we can connect other 12-volt accessories later. Next, I'm gonna wire up the Sabaton 3-speed connector for eco, normal, and sport mode.
So I'll make a 3-pin connector here with 2 wires coming out of each pin. That way, the first set of wires can go straight to the controller 3-speed connector, and the duplicate set of wires can run to the CT22 for indicator lights later.
I labeled the wires with low speed, high speed, and on ground, I just wrote Sabaton, so I remembered that this 3-pin connector goes to the Sabaton low high speed. Next, we'll grab our 3-speed switch, which already has some pins on it. We'll also grab a male and female connector of our choice. I'm out of 3 pins, so I'm gonna use a 4-pin. I'm gonna put the pins from the 3-speed switch into the connector now, taking no mind to order. And now I'll grab 1 low, 1 high, and 1 ground from the Sabaton connector and pin those. Now we'll pin up the other side of the connector, making sure to use the female pins as this side of the connector as male. Now we can plug the 4-pin together, plug low into green, plug high into red, and plug ground into black. And with that all plugged in, just verify your connections go to the right spot, and now our 3-speed switch plugs into our harness. With that out of the way, let's start wiring the indicators for the high/low speed into the CT22. If you'll recall, that's a fun one because it uses a few diodes and a relay. So as we discussed briefly earlier, the relay has 5 pins on it. These relays, while they can handle plenty of amperage and power for our needs, are typically meant to be used on surface mount configurations. That means they're usually soldered to circuit boards. That being said, I've used them in bikes plenty of times for years with no issues at all. You just have to make sure that the wires are strain relieved properly and soldered well. So we'll take the top left pin and solder a red wire to it for our plus 12 volts. Now we'll take a black wire and let's solder up our minus. Now if we remember, this minus doesn't go straight to ground, it goes to the diodes that go to the switch. We do, however, have 1 more wire that goes straight to ground. When you're done soldering, the relay should look something like this. I went ahead and labeled all the wires.
And wrapped it up in electrical tape, which we'll heat shrink over later.
We can go ahead and solder the positive straight to 12 volts, and we'll solder the middle input wire straight to ground. We'll grab that ground from the Sabaton 3-speed connector. And let's splice some wires. Here we have the high-speed wire from the Sabaton, and we'll splice it in the middle there, and we'll take the anode or negative side of the diode, that's the side with the gray on it. Then we'll take the low-speed wire and do the same. Clip that, solder that, and heat shrink over both of those. Now these 2 diode wires will connect together and connect the negative side of the relay to turn the relay on when either of these diodes get power. Next, we want to wire up the 2-pin connector that's going to go to the headlight switch. So we'll grab a red wire and solder a female pin to one side of it, and we'll solder the other side to 12 volts. So let's get ourselves a 2-pin connector and wire that up. It doesn't matter which goes where because we're just connecting to a switch. Now we know the output from that headlight switch goes to this. So this switch assembly is the next thing I'm gonna add. All right, so we've got this connector. Now let's grab the 9-pin connector we made earlier. Let's find the wire labeled headlight input, and we'll attach 1 more pin to that. And now our headlight switch is part of our harness. Let's take the other 2 12-volt inputs from this connector for the horn and the 12-volt signals. Let's splice those, and we'll run them to our 12-volt cluster, which is starting to get pretty big. Now all we have left coming out of this connector are our turn signal wires and our headlight wires. Let's start with tackling the headlight. For the headlight, since you have 4 wires, you might want to make an extension out of 4 conductor wire. I didn't have any, so I prepared this. Now the headlight uses a spade connector for ground and bullet connectors for the DRL, low beam, and high beam. Let's strip the other sides. Use my meter in continuity mode to see which one is ground Find ground on our main harness and splice that in. Next, let's grab our low beam wire from our 9-pin connector, splice it, throw some heat shrink on it, and connect the headlight wire that'll be our low beam, leaving some more wire that we can run to the CT22 display. Now we'll grab the high beam output, splice it the same. Then for our last red wire, which will be our DRL, that's gonna get 12 volts the whole time. I don't quite have a lot of length on it. I'm gonna take another wire and we'll splice it on here. Now I'll cover this whole mess of a solder joint that distributes all our 12 volts. And I have 2 more wires coming out of it. One of them will go to the headlight. I'm gonna leave another length of red wire for anything else that needs to get connected to 12 volts later. Now all that's left for the headlights are to plug in the high beam and low beam wires to the indicator lights on the display. So let's pin those 2 wires. And with those 2 pinned up, we'll connect low to pin 6 and high to pin 7 on the CT22 connector. All right, so next up I want to wire in the turn signals. Since the turn signals each have 3 wires, if you had a 3 connector wire, it would be best, but I don't, so I went ahead and made groups of 3 wires and cut them to length. I have 2 of a shorter length that'll run to the front turn signals, and 2 of a little bit longer length for the rear. The turn signals have bullet connectors on them. So the first thing I'll do is put bullet connectors on one end of all these wires. So now that we have bullet connectors on all of these wires, we can go ahead and start connecting them to our main harness. I'm gonna go ahead and join all the grounds together first. Since I ran out of black, I'm using green and black wire for ground. I'm also gonna grab a ground from our main harness, and we'll grab a decent amount of heat shrink, and we'll join that all together. Before I connect the signals, I'd like to connect the 12-volt DRL. The red wire and the 2 short cables will join together, so that way both front lights have 12-volt power to the daytime running light whenever the bike is on. I'll splice this 12-volt wire from our harness, leaving 1 more length on it, get some heat shrink, and hook that up. Next, I'll grab the red wires that run to the rear turn signals and connect them because those will be our brake light. I'll come back to the brake light in a second when it's time to wire it to the brake lever. I'm gonna make 2 groups of 1 long and 1 short wire, and I'll label one of them for the right signal and label another left. Now that I've labeled the wires, I'm gonna grab the left signals and join them together. I'm also gonna grab the left signal wire from our 9-pin connector from the switch cluster. Before connecting those 2 to the switch cluster, I'm gonna pin 1 more wire and join it with the other 3, and piggyback off that connection for the CT22's left turn display. Now I can find our CT22 connector and run our new pin over to pin 9. Now I'll repeat that process for the right turn signal. And with that process repeated with the right signals and plugged into pin 8 on the CT22, that completes our signal wiring. Let's take a look at our brake levers. They both have this 2-pin connector on them. So let's grab 2 2-pin connectors and 4 pins. These are female pins. Since we want either of these brake levers to close the circuit, we can wire up these connectors in parallel. And with that, we'll connect one of those wires to the brake light, and the other wire gets 12 volts. I'm gonna leave that uncovered so we can wire our DC-DC into it. Next, I wanna wire up our 5-volt USB charging port. To make 5 volts, we're gonna be using this DC-DC. The DC-DC doesn't come set to 5 volts automatically. In order to set the DC-DC to 5 volts, you have to apply a voltage to it. So we're gonna plug 12 volts into it and wire up to the in ports. Next, we'll grab our multimeter, set to voltage mode, and we'll check what we're getting on the output. Right now, we're getting around 12 volts on the output, and we're also putting 12 volts in. So right now, the DC-DC is not set anywhere where we need it to be. To set the DC-DC, you're gonna need a small screwdriver to turn the potentiometer on the top. In order to tune the DC-DC, you need to turn the potentiometer left until the voltage outputs 5 volts. Awesome. So we can turn this off, and let's wire it in. On the output side here, I'm gonna use these JST connectors because they're what I have available. But you can use anything you want, as long as it's smaller than this. With the connection soldered and the voltage set, I'm gonna heat shrink over this for protection. While I've got the heat shrink out, I'm gonna cover a few things. Now we'll connect this in with our 12 volts, and we'll link that up with our ground. I'll connect the JST to the USB, and we need 1 more 2-pin connector that we'll use for our horn. I'll grab the horn wire, and I'll grab that last ground, and we'll plug those into the horn connector, and we'll grab the horn, which has some spade connectors on it, but I don't like these connectors and I'm out of spade connectors, so I'm gonna solder some 2-conductor wire to these.
And we'll throw the same 2-pin connector on the other side.
How long is your clip?
And with that, we only have one more wire to do, and that's the hall meter that connects to the green hall meter line on the Sabaton. So one side gets a bullet connector, and the other side gets a pin for the CT22. We'll find our CT22 9-pin connector, and the only pin not used yet is our hall meter. Let's take a minute, neaten this up. I forgot to connect the brake high wire for the Sabaton, so the Sabaton doesn't know when I'm squeezing the brake. I'll trace back the connectors that go to the brake levers, and I found the junction here where we connect the brake lights to these levers. I'm gonna open this up, add my spade connector, and resolder. We're finally done making the wiring harness. As far as harnesses go, this is a pretty complicated one. Sometimes you can save space by skipping on connectors, and sometimes you can make it look a lot neater if you're building it inside of the bike, but it's a lot harder to film inside the bike, and for the purpose of this video, this will do just fine.